Okay, today I'm going to show you how to do these questions. So this is the question by using integrations to prove these inequalities. So we're going to find three different areas and using the different size of the area to prove it. So two of the area we're going to use the integration to find the area. So that's why the question is starting with proving two integration questions. So let's do the first integration questions. Question AI. So integration of this to log, it's a base e of x minus 1 dx. So I'm going to do integration by parts. So u equals to log x minus 1. So u dash is equal to 1 over x minus 1. V dash equal to 1 and v equal to x. So the integration become x log x minus 1 with the limits 2 and k plus 1 minus the integrations of x over x minus 1 dx with limits 2 to k plus 1. So it's become, I'm going to leave this part here at the moment, k plus 1, 2. And the second half of the integrations, I'm going to do some manipulations to make things easy. So I'm going to minus 1 here and plus 1. So then you can easily integration now by changing it into 1 plus 1 over x minus 1 dx. And then we can integration. So minus x minus log base e, they are base e x minus 1. So then I'm going to tally them up, become x minus 1 log x minus 1 minus x. And with the limits 2 and the k plus 1. So then we sub in the limits, the answers, then we can prove. So that equals to k log k minus k plus 1 after we submit the limits. So that's the first half of the questions. So very similarly, with the integration by parts, we can also prove the second integrations. So let's just say second integrations we proved. So log 2 to k plus 1 log x, that equals to k plus 1 log k plus 1, and then minus log 4 minus k plus 1. So we now proved. So how do we using these two integration to prove the question B? So the question B is the three inequality you can see. So these three inequality is basically are three different area. So the first question we proved the integration is the area under the y equal to log x. And the second one is the area under the curve y equal to log x minus 1. So if you can see here, I'm going to draw it. So the first one is this area here. The blue area here, the first one. So you can see this blue area is the most area compared to the second one, which is if I using the yellow area. So this is the yellow area here. So definitely is less than that's under the second curve. It's less than the blue area. And then where's the middle area? Middle area is created by those rectangle. You can see the first rectangle is here. Second rectangle is here. And then you have more rectangle and the more rectangle. And the last rectangle is there. So all these red rectangle, the area will be in between the blue and the yellow. So it's less than the blue but bigger than the yellow. So what is the area of this rectangle here? I'm going to do here. So the first rectangle area is, you can see, is the width from 2 to 3, and the height is the point is landing on the curve. The curve is y equal to log x base e. So the y value for this point would be log 2. That's the height of the first rectangle. So the area of this rectangle is width is 1 times log 2. So it's log 2. So that's the first one. And the second one you can see is log 3 times 1. So it's just log 3. And the next one will be log 4 times 1. And the last one you can see is the log k times 1. So the total area will be this, all these area plus together, which give you, we're using log, become log 2 times 3 times 4 all the way to times k. So that give you is log k factorial. So this is the middle area, the rectangle. And the first answer of integration is the blue. And the last integration is the yellow. So I'm going to highlight this, the yellow and the blue. So the yellow is the last area here, which is this one. That's the yellow area. And the blue one is here. That's the blue area. So a blue area bigger than the red area and bigger than the yellow area. So I'm going to using all these three areas, put into inequalities. Okay, so let's move on to next. So I'm going to write down. So the k log k minus k plus 1 is less than log k factorial, and is less than k plus 1 log k plus 1 minus log 4 minus k plus 1. So this is the three areas in that order. So I'm going to just tighten them up and then prove the last inequalities. So the k log k is the same as log of k to the power of k. And the minus k plus 1, I'm going to plus k minus 1 on every side of inequalities. So it's become log k factorial plus k minus 1. And the less than, here I put a k plus 1 to the power here. We're using log loss. And also minus log 4. And also a plus k minus 1. So that's gone. So, and now I'm going to e both sides everywhere. I'm going to e both sides, which is going to e both sides. So I'm going to e here, and the e here, and the e here. So then after that, I'm going to using log loss. So e log base e kk just become k to the power k. So less than e log base e k factorial just equals to k factorial. So become k factorial here. And of course times e to the power k minus 1. And the less than, same, k plus 1 to the power of k plus 1 And because the 2 log minus means divide, so it's become over 4. I think that's proved the questions.